This is our last talk in the Docker in Production track. Thank you for coming. We have representatives from Franklin American Mortgage Company here with us. They're going to talk about disruption from within, how Franklin American is doing innovation in the enterprise. So let me welcome up here Sharon Frazier, Vice President of Innovation, and Don Bauer, also known as DevOps Don on Twitter, lead DevOps engineer. Let's give him a hand.
Would you like a clicker?
Yes. Okay, hello. With the lights, it's really hard to see, but that's okay. We got an empty room, doesn't matter. Sharon Frazier. Oh, when I touched the mic. Just a little bit about what I do. I'm actually an entrepreneur in corporate America. I've been involved in a lot of startup and early stage companies most of my career, and jumped into corporate America because I looked at the opportunity with the company and the ability to disrupt the industry from within the company. So I actually get to run a startup inside an organization, and it's the best job in the world.
And I'm Don Bauer. I'm a community leader for Docker in Nashville. I was brought on as a DevOps engineer at Franklin American Mortgage to help them build out their new platform to facilitate their microservices strategy, their DevOps desires, and everything we wanted moving forward. I've been using Docker for about 3 years, 2 of which has been in production at 2 different companies actually now too. So I've been a software developer most of my professional career. Over the last 2 years or so is kind of when I transitioned into DevOps, and it's been a heck of a ride.
Fair enough. So let's just talk about innovation for a minute. It's something that we hear a lot about, right? Everybody's doing it, or everybody wants to do it. It's important, but it means something different depending on who you're talking to. So I wanted to give you my definition. First of all, I'm going to say that innovation isn't about the latest and greatest tech. I mean, it can be, and I know it's a hell of a thing to say at a tech conference, but any tech's only as good as what you do with it, whether it's new or legacy or whatever. But in innovation instead, you got to look from your customer's point of view. It's got to be enabling something that's new and important to them. Just because you've got a new product or a new feature doesn't mean that it actually matters to your customer. And if it doesn't matter, then you no longer stay relevant. Another way I describe my job is it's my job to make sure that the company is still relevant 10 years from now. So the first challenge we wanted to address was actually our competitive position with pricing. Now, any company that's greater than 10 minutes old has some sort of legacy, whether it's processes or systems or culture. Some of our oldest tech was in our lock engine. Some of our most complicated tech was in our lock engine. And for those of you not in the mortgage industry, what a lock engine is, it's where our customers come to get prices about our loans, our products. So it's incredibly important to us and to them, because if we don't lock loans, actually we're out of business. So the team set about to reimagine locking. So we didn't want to just recreate what we had. We wanted to look at it from a completely different point of view. What we did know was that we wanted to deliver a modern app that was the most dependable, the most hardened, and the most flexible. We wanted to give the business the agility that they've been missing and they've been wanting. We knew also that it was going to be the beginning of our platform. It's going to be the foundation that we were going to grow from, because we've got a lot of things that we want to tackle. We knew that it had to embody the quality of service characteristics, your security, your adaptability, high availability, all your abilities. We also knew that we wanted to deliver in a continuous or operate in a continuous delivery fashion. We knew that we wanted to be able to stand whatever we were creating up anywhere. We didn't want to be limited to any sort of data center or platform. So in essence, we knew we had to create our own foundation that we could work from, which meant we were going to eat our own dog food, which was actually a really good thing.
All right.
Your show.
So with everything that Sharon just said, all the considerations we had going into this, it was important for us to come up with a solution, like she said, where we could eat our own dog food, remain agile, but we didn't have a big team, so we had to take all of that into consideration as well. So we started looking at solutions, we started looking at options. At Franklin American Mortgage, from the day I started, they've had a strong focus on doing things right rather than doing them fast. And we kind of wanted to do both, but we wanted to make sure we made the right choice no matter what. So we wanted to meet our current and future needs with what we went with. We ended up landing on Docker Enterprise. Unlike other options at the time, it was going to be simpler to maintain, and more importantly, I mentioned our small team, and we needed something that we could maintain with 1 or 2 engineers over the life of the platform, at least at the beginning. But we also needed that same level of service isolation, and so Docker EE let us isolate our services between a staging environment, test environment, and production environment, all within a single cluster. That's how we landed there. There were other options like Kubernetes that, even though they were more feature-rich at the time, they were hard to maintain, and they didn't offer that same level of segregation. With Swarm, it simplified how we were going to deploy our stuff, and it eased processes like user adoption across our organization. And again, it was just much more simpler to maintain than a lot of the other schedulers. So with Docker EE, it enabled us to move forward with something else that we wanted to adopt with our new software strategy, and that was continuous delivery. So we identified that as how we wanted to move forward. But once we started looking at the tools that were out there, there wasn't really anything that integrated with UCP or DTR or Notary in anything more than a generic capacity. We had some specific needs that we really wanted to tackle for some of our forward-looking stuff, especially with Docker Content Trust and image signing. So after we looked through the process of customizing some of the other options that were out there with plugins, things like that, we made the decision to build instead of buy. So once we decided to build, we set out to make the tool that we built not only a CD management tool, but something that would be a single pane of glass into our cluster and into the state of our ecosystem at any point in time, and it's really enabled much of our success. So when we first launched it, it was only running about 30 services, it was only managing 3 environments, and we were doing maybe 2 to 4 deployments a day. Funnily enough, the delivery was the first deliverable delivered to the company by the innovation team, and that's just fun to say. So delivery is pretty cool, and I could talk about it all day. But I won't. I wanted to talk about the more important things about what we did, which is how we decided to do what we were going to do. We had to define DevOps within the company, what it meant to us, because you talk to people here or just about anywhere in the community, DevOps means something different to just about everybody. So we had to define what DevOps meant for us, and then we had to define our vision. So for us, DevOps is way more than just simply automating the software development lifecycle and simplifying remedial tasks. For us, DevOps is about breaking down the barriers and removing teams from their silos and getting everything set up for collaboration and communication across those teams. We wanted developers to be thinking about the operations required to run their applications, and we wanted the ops team to be thinking about the developers when they were setting up their stuff. So I personally feel that if a DevOps team is ever 100% truly successful, at the end of that success, there will no longer be a need for that team. But luckily, technology's moving pretty fast, so we get new challenges and stuff, so any DevOps engineers in the audience, I don't think you guys have to worry. As for our vision, that's what we set out to define next. So these are the pillars of our vision that we've brought into our DevOps culture. Pillars are visibility, simplify, experiment, and standardize. They're not necessarily in that order, I messed that up, but they're now not only the pillars of our DevOps vision, but they're actually now pillars of our DevOps culture. When we think about decisions we're making moving forward with anything we're doing within our IT ecosystem, we look at it through these lenses now to make sure it's enabling us to do what we set out to do in the first place. So for the purpose of this talk, I'm not going to cover things like if we went waterfall, if we went agile, if we're using Scrum, cabs, ARBs, that kind of process stuff. We just don't have enough time for that. But instead, I'm going to focus on the pillars of our vision and how Docker and delivery have enabled us to accomplish what we have. So the first pillar we tackled was visibility. Visibility is the foundation of our DevOps culture at Franklin American. There should never be the question asked, what are you guys doing over there? But more importantly than that, visibility across teams. It enables communication, it enables cross-functional growth on both sides or all sides between your developers, your ops teams, your administrators. And it creates an environment that fosters personal and professional growth. And that's been very important for us as a company. The other big thing is it helps to break down the silos. I touched on that a little bit earlier, but it does help break down those silos. And once you get the teams talking to each other, it kind of never goes back to the old way, and that's what we've wanted to see. So as we continue evolving as a company, visibility being the foundation of our DevOps culture has really started to spread through everything else. So now it's taken into consideration through all processes and changes and projects that are happening within the company, not just within IT. So the first thing we tackled under this pillar was monitoring. Once your service is deployed, now what? So we utilized the UCP API for the basic container monitoring, provided a simple dashboard within delivery to just quickly identify healthy services. We implemented the Elk stack for free open source log aggregation using FileBeat deployed across our cluster. And we integrated with a company called Instana for our APM and kind of infrastructure monitoring. And they actually did a talk yesterday in the ecosystem track. I hope you guys got to see it, but if you didn't, they do have a vendor booth in the expo hall, and you'll want to talk to them for sure. So when I was a systems engineer working for Charter Communications, this was about 8 years ago, my boss used to tell us, if you can't monitor it, then it never happened. It's kind of, if a tree falls in the woods and no one's around to hear it, kind of a thing. If you don't know it went down, then is it really down? So this is a tenet that we've adopted and we've brought into the culture, and it's something that I've personally lived by ever since as a developer, as an infrastructure engineer, and now as a DevOps engineer. And as most of us know, root cause analysis is one of the hardest parts when it comes to monitoring, especially when you're triaging some sort of outage. So within our dashboard, we built in links to UCP, to Kibana, to Instana for all of these services when an event does happen. So we can link you to all the relevant information at the same time, rather link our developers. And then we added real-time notifications in our Slack channel. We have a nag mode that will constantly make sure you're aware if it's a critical service or a prod service. And thankfully, we've got that down now, so we haven't had too many of those, knock on wood. Yeah, Sharon's over there knocking. So the next thing was pipelines. And so this is a widely abused term. And I'm not going to try to necessarily define it here, but what we wanted was a simple way of getting services from development all the way to production. So we needed our tool to do that, give us one way in, but we also needed to be able to see visually what was deployed to every environment for every service at all times. And so we created this dashboard. This is just a little snippet of it, but it shows you the current running version, where it's running, whether or not it's healthy. That's the background color. And the same dashboard allows release managers and stuff to see what's going on and promote if they need to. Most of it's automated, but you have the manual option as well. So it enables and enforces it enables and enforces the one-way to production paradigm that we wanted to follow. We don't want anybody, testing it in prod, anything like that. And this has allowed us to do that. As we started to introduce user sandboxes, we enabled our pipeline systems to automatically update those user sandboxes if they were running the same service that just got upgraded. Once it gets deployed to prod, all the user sandboxes would get upgraded as well. But we'll touch on that more here in a little bit. The same view, like I said, also enables the release managers to promote new services if they need to. If we have a manual QA portion, the QA engineer can go in and sign off and move it on to the next stage. So everything follows the same process to get to production. So the next thing, and this is everybody's favorite thing right here, is compliance. So a lot of companies have to follow SOC, ISO, PCI, NIST. I mean, the list goes on. For us, with DTR that you get with Docker E, the image scanning really helped us check the box. So we could immediately address and identify those concerns, and the security team can quickly go in, see the scan results, they can look at all the images, they can handle the updates. And we just maintain that visibility across the teams. It's also allowed us with their API to enforce a baseline, so we can automate that part of the process where if there is anything critical that needs to be remediated, it will get remediated before it's promoted or deployed anywhere. Their API has allowed us to automate a lot of that process, and they've made it really simple to extend and tweak it as well. So the next pillar was simplification, or to simplify. And developers, in my experience, or at least good developers, are lazy. Developers will create services and interfaces using common standards. I used interfaces in the wrong spot there, but common standards, interfaces, and patterns. And as we started to move forward with our DevOps initiative, we thought, well, why don't we do the same thing with everything that we're doing? So the first part of that was actually implementing D&D. And no, I don't mean Dungeons and Dragons. But I do mean Docker and Docker. Has anybody in the audience used Docker and Docker? I'm actually kind of surprised. There's more than I thought. Well, for those of you that haven't, if you're not familiar with it, it's exactly like it sounds. It's running a Docker container to run a Docker engine to then run some more Docker containers in there. But I have hallway tracks for this if you want to know more about it. I won't get too deep. But at this point, you might be wondering how running Docker in Docker actually helped us simplify anything. So the first thing was it comes back to us eating our own dog food, as well as the need to maintain the isolation within a single cluster. So we're using the single cluster to help facilitate this workflow, but that cluster might also have production services running on it. So Docker in Docker allows us to add that second layer of isolation, and it also made it so it gave us a path where we could enforce and honestly simplify a whole lot of how we handle builds and deploys. So we started with a base image, and in that base image we put all of our build scripts, all of our deploy scripts, and then any tooling that might be needed to push artifacts to repositories or move them somewhere else that they needed. Our DTR image signing stuff is all in there as well. And then we would extend that base image based on the project language. So if you were running a build for a Java language, you might need Maven, you might need JUnit to run your testing. We were able to centralize all that in one spot and then extend it. And then if we have to apply an update, we have to update a build script, something like that. We only update that one spot. Our CI process trickles it down to all the other images. And these are single-use images. So they only exist for 5 minutes at a time. Once we roll out the new scripts or the new keys, whatever we have to do that way, we're guaranteed within 5 minutes and nobody's using the old scripts anymore. So it's allowed us to simplify that process, so we're not maintaining build scripts and deploy scripts across 300 repositories. We just maintain them in one spot and everybody follows a standardized pattern. The other big thing with it, like I said, it's single use. It's allowed us to really dramatically scale out how we do our deployments. All of these can run, we can run 25 concurrently, we can run one at a time. It doesn't matter that way. But now that we don't have to worry so much around bringing the tooling into the repositories so these guys can run their builds, it's simplified the management of that, and it's also made our images a lot smaller in the long run. The next thing is standardization, and I mean, this kind of ties back into simplification a lot. As the slide says, naming things is hard, and I'm sure a number of us in the room have been pulled into meetings because we got to figure out how to name this next thing because it conflicts with something else we've already got, and nobody likes that kind of stuff. So we started with our images, and so we kind of followed the same model as we did with D&D. We started with a base image. We actually have a couple because not everything runs on Alpine, unfortunately. And with that base image, any of the tooling and stuff that we need or require for compliance reasons or standardization reasons, we're able to put it in there. And then we extend that again for the languages and runtimes that are going to be used by the applications that'll get deployed as containers using these images. So the same thing works there where the updates to the base images trickle down. From a security perspective, if we identify a vulnerability, all we have to do is update the base image and trigger builds downstream, and we've got that vulnerability covered across all of the projects. And again, it simplifies everything. So they're just going from one of these base images, injecting their artifact, and they're good to go. The other thing was metadata. So we standardized our metadata in our Docker files. So there's a standard template that everybody gets when they start. There's a skeleton project that they basically just clone. And with this, with the metadata, what we've done is we've identified some very important pieces of information that we commonly need, especially from an operations perspective, when it comes to troubleshooting and triage. So we track the artifact ID, the build date, the hash of the VCS commit that was made, and the semantic version. There's some other stuff in there as well. This is a little bit trimmed down for this because it's a lot of information to put on a slide. But with how our logging and stuff works, any log entry that we pick up, all of this information is included, and we can of course see it inside of UCP. We can see it inside of our delivery tools, any of the monitoring that we've got around it as well. All that metadata is going to be attached to the running image. So if we have an issue with it, we can verify what semantic version it is, and we've got the exact repository URL and git hash of that commit, so we can immediately go identify where the issue is. It's really simplified the triage process, and just I'm not sure I can really say any more about that, but we do get very good feedback from the devs. They no longer have to look anywhere to try to figure this stuff out, because the last thing you want them doing is shelling into the container and digging around trying to figure out what version it is. So next we moved on to the swarm templates, and our goal here was we wanted the templates to be simple. I don't know how many people in here use Swarm versus any of the other orchestrators or schedulers out there, but it's the same as a Docker Compose file, which I'm sure you probably know. But we wanted them to be simple, and we wanted them to be deployable using Docker Compose on a local machine, but the same template could be used on our cluster to deploy that service to the cluster. Delivery helps us out with this a little bit, so it'll auto-prefix things like networks and volumes based on the environment, but no actual change is required in the Swarm template. Part of what's enabled us to do that is the standardization of environment variables surrounding that, so we can tweak how it gets exposed if it's exposing a public endpoint. And some of the namespacing stuff, but that's all handled through environment variables, so the actual template doesn't change. This ensures that we've got identical configurations between what's running in test, what's running in staging, and what's running in prod. The other big thing that this has really helped us with is when we do bring a new developer into the fold, it really simplifies the ramp-up time, because they can just come in, they can Docker Compose up the same template that we're using to run these deployments. So when these do get deployed, I mentioned our delivery system does some auto-prefixing. So here you've got a set of volumes that are all deployed for our Zookeeper service, but you'll see 4 different environments called out there. And then the same thing on the network side, that's all for our Zookeeper network, but there's one for staging, there's one for prod, and there's one for test. So they're all isolated and kept away from each other, and if you've got the right rights, you can see them, but using the collections, anybody else who logs into that cluster wouldn't otherwise. But it sets it all up the same way for everybody. So at this point, we've covered the first 3 pillars, and they've enabled us to tackle our 4th pillar, which I don't want to, it's not the most important, but in terms of innovation, it is incredibly important. We wanted to enable our developers to fail fearlessly, but fail fast. And this is something I say quite often, so anybody who's talked to me here at the conference, I'm sure I've probably said it once, at least. But we wanted to enable our pillar of experimentation. Developers should never fear failure, and for that matter neither should engineers. We should be able to try new things quick, we should be able to evaluate them, and if they're not going to work, we should be able to fail quick. So our first thing with that was sandboxes. We did single-click user sandboxes, so any user can go into the system and they could say, hey, I need these 2 groups of services, and I need this one to be at this version, and they click a button and they get their very own private sandbox within our cluster that they can then interact with and develop against without having to run 87 services on their local machine. The isolation and the nature of how Docker EE and Swarm sets this up has really allowed us to do that. We can copy any running environment in minutes, whether it's running 30 services or 120. And with the role-based access controls, we've been able to lock it down. So if Joe deploys his sandbox, I can't do anything against that. That's Joe's sandbox, and vice versa. Joe's sandbox can't talk to mine or prod or any of the other environments for that matter. So, like I said, sandboxes can be deployed with a single click, but they don't have to be. You can customize it. So this is just a loop of kind of what that looks like. But the other thing I touched on briefly earlier is they're self-updating. So any of these where I haven't specified a specific version, if tomorrow 3 of those are updated and a new version of those services go out to production, the system will go back to my user sandbox that I just deployed, and it'll automatically update those running services to match the latest version that was just launched into prod. So this has allowed us to operate temporary sandboxes used for one-off testing, as well as long-term sandboxes used for developers, using the same mechanism, the same interface, the same everything else. So I touched on failure, and failure is easily one of the most important things for any engineer or developer, and it's what separates the good ones from the bad ones. Failure is how we as human beings just learn best. So by adopting and integrating the other pillars of our vision, we've created a platform that allows us to fail, because there is no success without failure. So if we can fail fearlessly, we can fail faster, we can get to success faster. So that was our vision, and now it's our culture, and that's just some of what we've done. There's a lot more that we could touch on, but I also wanted to be able to present some stats about what this has enabled us to do. So I mentioned when delivery was born, we had maybe 30 services, 3 environments. We were doing 2 to 4 deployments a day. Today, we're doing about 1,000 containers on our production cluster. We're running 300 services. We've got about 20 different environments, and we're adding 2 new services to that inventory every week. We've had over 100 user sandboxes created, 200 automated deployments daily. And on the health and monitoring side, we've resolved most of them automatically, over 25,000 health events. And since delivery was born on November 17th of last year, we've done over 10,000 deployments with the platform with Docker EE. So I mean, if you do your math, that's only about 8 months, and that's how far all these pillars have let us go. So that's what we've been able to accomplish so far. So the real question's, what's next? Because we should always be looking forward, and that's one of the things we wanted to enable. And you know, lots of big announcements out of DockerCon this week, and I know some of you that might be using EE. Of course, Docker EE brought in Kubernetes with their latest 2.0 release. So that's going to play a big role, but I'm going to let Sharon kind of talk about some of the future state for what we've got going, and if we have time, we'll take some questions if anybody has them.
Sure, absolutely. So actually, the only thing there's a lot that we've got going on that we want to be doing. But we're going to take what we've learned and what we've done for the software side, and we're going to apply that on the data side. So I'm really excited. I've got a team in place where we're going to start to tackle that, and we're going to do our analytics in a continuous delivery fashion as well. And from a software side, we will be continuing to dismantle pieces and parts of our legacy and reimagine the business around those parts, and just keep disrupting what we can. That's all we got. So if you guys have any questions, I don't know that we'll be able to see.
Oh.
Thank you, Sharon.
Sure.
And, Don. If you guys have questions, there's a mic right back here. I'd ask you to walk over to the mic and kind of queue up there. We have time for a few questions. I have a couple if we run out of questions.
First of all, thank you for the wonderful presentation. I think it was quite insightful. And additionally, the pace at which you have perhaps achieved the elements that you showcased are quite commendable. That said, I have a few questions that come in mind, and these are like interrelated. So first of all, when you started off on this journey and put together the element of automation in terms of deployments, so on and so forth, right? So did you build it grounds up, or did you have like a template or a product that you used to undertake the deployment part? So what I mean by that is, you said if a developer wants this environment, this component, this part, he's able to choose that and then tie it together. And then there are a lot of elements that go into it, like the networks and DNS and the firewall ports and all of that getting aligned and that getting configured and provided to the developer. So how did you go about doing it, and what technologies did you use or products did you use?
Okay, well, that's a great question. So there's actually a wide array of things that kind of went into that. So as a tool, it was written in Go. The API was written in Go. The front end is all TypeScript with Angular 4. And then as far as the other supporting technologies, there's some service discovery stuff that does run on our Swarm that helps with things like endpoints and DNS and whatnot that way. It'd be really hard to get into all of those now, and I'm more than happy to have that super deep dive technical talk.
I'm sure.
But I'm not.
No, I understand what you mean. So I just wanted to get a view, and considering all of that, this was built. There are two parts in terms of people that I wanted to ask. So your project team that actually built all of this together, how large was the project team?
It was 2 people, and in fact, we're both in the room.
That's excellent.
And she's not
That's
the other
awesome.
one, actually.
No.
But it was 2 engineers, myself and then my former colleague Kevin Crawley, who's sitting in the audience over there.
Hi, Kevin. And they were actually embedded within the innovation team, and my team is cross-functional. So I've got architects, I've got engineers, I've got front-end engineers, user experience, product managers. We had our DevOps. So we incubated the discipline within for what we needed, and now they've graduated to the operations team because we're expanding on what we're doing. Sorry.
And that was actually my next question around operations team. So I'm assuming that you run some 24/7 in general, because you may have teams that are spread out, so on and so forth. So you operate this 24/7, so it needs to be manned. I don't know, maybe 24/7. So how large is your ops team, and how is it structured? Is it blended with your legacy support team, or did you create a new team to specifically look at these elements?
So you're asking if the old team is helping support with the new stuff, or?
Yeah, so my question is, say suppose Swarm goes down. Right? Okay. What happens?
So
Who does it? Yeah.
We're kind of doing our stuff alongside, so we're bringing in more of the legacy operations folks and developers. What's been really interesting about that transition, because of what we've done, is we're not necessarily going to them and saying, hey, here's the new way we're going to do things. Here's the new platform you're going to operate on. They're coming to us and saying, hey, we want to do that. We want to be a part of that. So it's made the transformation within the company a lot easier. But initially, we stood up our team alongside what they were already doing. So they helped us get some stuff started. We got some processes and standards in place, and we've been kind of managing both the platform and the process ourselves. But now it's spreading like wildfire, and everybody's wanting to get in.
Thank you. Thanks for your time.
Yep.
Thank you. Very great presentation. I'm wondering about how you continue to innovate when you, once you've kind of got it to scale, and how this is affecting the other operations teams that are maybe still supporting the, kind of more legacy and traditional apps.
The other operations teams are ecstatic. They can't wait to get the rest of their stuff Dockerized, because they've, like I said, they've been very involved in this process so far, but most of that's been kind of helping us accomplish what we were wanting to do, and now they're going out and they're doing the same thing that we do with our community leaders and our captains. They're being advocates for the platform, and they're helping everybody else move it over. So, I mean, there's still going to be some needs there, but the biggest thing we've seen shift with the operations team mostly has been kind of the mindset they use when they're working on something new, or they're building out new things. You know, if they need to go build a new server, for example, they used to just hop into VMware or something and build it out and run the whole thing. They might spend half a day on that. Where now they need to go build a new server, they're thinking about it from those pillars, and they're like, well, let me see if I can simplify this and standardize it. And they're building, you know, Ansible playbooks to do it. So next time they get asked to do the same thing, they tweak a couple variables, they hit a button, and you know, that kind of culture kind of spreading through some of the legacy teams and organizations, you know, has made a big shift and big difference. Did that answer your question?
It did. Thank
you.
One more question is, you made a choice early on to build instead of buy some of your tools, and I'm wondering, now that it's been a while, you're looking back, you've got that retrospect, did you make the right choice?
I think given the options we had at the time, I truly believe that we did. The landscape changes so fast, though. So if we were posed with the same decision today, it'd be a harder sell. But I think given what we were trying to do and how fast we were trying to do it, that we absolutely made the right decision.
Thanks.
Yep.
All right. Thank you again, Sharon and Don.
Thank you.
If we can get a big round of applause.
Thank you. There it is.
I think that they will be around if there are any additional questions, if you want to just talk to them one-on-one.
Yeah, absolutely.
They're over here or in the hallway.
Yeah,
I don't know where
we'll hang back for a little bit if anybody else had anything else they wanted to talk about.